Now that you're all warmed up mathematically, let's do a harder problem. This one is all you guys. Here's a situation where you got three identical charges lined up on the y-axis. I want you to figure out what is the electric field at position x. So start by figuring out what direction that electric field is going to point. You've got three different electric fields. Draw those vectors at x and add them up. Which way is that going to point overall? And the next step, we need an equation. This is like the problem with the dipole. You've got three different electric fields, and you're just going to add them up. But because they're vectors, you can't just do kq over distance squared and add three of those, because they don't all just add, they're vectors. You need to figure out which components overlap and add those components. So do that. It's going to be ugly and take you a while to type on Canvas, but those two questions go in term on Canvas. Oh, and after you've got your really ugly equation, a way to check whether or not it's right, because when you look at it, it sure doesn't look right. You got to look at limiting cases. So for example, when x is really, really big compared to d, when x is super far away, you can't even tell those three charges are spaced apart. They just look like one big 3q. So look at your equation. If when x is much, much bigger than d, your equation simplifies to the electric field of a 3q charge, then you're on the right track. Similarly, if x is very, very small compared to d, you're just snuggled up against the charge at the origin. You don't even see the other two charges, and their effects cancel out. So when x is much, much less than d, you should get the electric field of one charge. Your big, ugly equation should simplify down to the electric field of a single charge. That's a way to check whether or not your ugly equation is right. So do those and enter it on Canvas. Let's go to the next slide. Working again on this idea of limiting cases, especially because this is stuff that we don't have good experience with. It's hard to have good intuition about electric field, especially when the equations are so ugly. So here's a situation where you've got slightly different configuration of charges, and I want to know when R is really big and you're very far away from this setup, what's the electric field going to look like? I didn't write these equations on Canvas, I just wrote the letters A, B, C, D, E. So pick the one that goes with the situation where you're really far away from all these charges. The next slide is very similar. We're going to look at the limiting case where R is much, much less than D. So when you're very, very close in, what's the electric field going to look like? Choose the letter, go enter it on Canvas.